All right. So, hey everyone, welcome to yet another live stream. As we move forward, just quickly confirm if you can see the screen and hear me properly. Meanwhile, you tell me that in the chat section. The agenda for today is simple. We will be solving more problems on LeetCode, probably DP. And if that is done, probably we'll do some greedy or arrays, some problems, something like that. So, this is my agenda. This live stream would be a bit shorter, for probably 45 minutes, and we'll be solving more and more, as many problems as possible with very little distractions, hopefully, this time. All right, cool. So, before we move forward, thanks to our sponsor, 𝗤𝗓𝗓𝗑𝗣, for sponsoring it in the live stream. It's a brilliant website for software developers. If you are a professional developer or if you are preparing for interviews, I think this is a great website. It has a collection of well-written, crafted courses on a lot of topics. And the good thing is, if you are a front-end developer and you want to get into Redux, which is very much heavily used with React, they have properly guided written articles in a course fashion. And you can also play around and write in browser VS Code, and you can see the output over here. So you don't have to waste your time in doing the setups. So it's a very quick way to learn things. They also have system design and React courses and other things. You can check that out. The good thing is, instead of buying courses individually, you can pay only once and get unlimited access to more than 300 courses on their websites. And that costs only $10 a month. They have 40% discount for Indians, but for my audience, you will get additional 10% off. So this amount that you are seeing over here will get further reduced down to this. All right. So with that, let's move forward with more lead code problems. Right now we are doing, I think, dynamic programming. So last time we did, I think, 3 problems, and now we will be moving forward. We're doing more problems. It's fine if you were not in the previous live stream. It is irrelevant because we do new problems in each live stream with like we approach problems from scratch, so it doesn't matter. Before we move forward, guys, if you are here, make sure that you first click on the hit like button, and while you click on the like button, I'll select few problems that we'll be solving today. And if you have any requests in the chat section, let me know that as well. Okay, so somebody is saying not trees. TypeScript, yes, I have used that. Soup servings looks something which I would like to do. Domino and Tromino, I think it would be something like how many ways to fill a matrix with 2 and 3 tile chips, something like that. We can do it. Let's see if something else. Shopping offers looks like something that I would like to do. All right. Okay, so the likes and dislikes ratio are really not that good. Um, what about shopping offers? And again, like all the problem links will be pasted in our Discord server. So if you have not joined that, here is the link. I'll paste that in the chat section as well. Some are saying graph, BFS. A lot of people. Okay, so one person is saying DP multiple times. I am good. Let's move forward with problems. Okay, let's do this one. This is not that bad as compared to this one, which is having around 650 dislikes and 200 likes. Okay, so let's see what this problem is about. I'll zoom in on the screen. And I'm pasting this in the Discord. So hopefully you are solving this with me. So just click on it and move forward. So there are n items in the LeetCode store that you have to sell, and every item is having a price. And there are some special offers, and special offer consists of one or more different kind of items with a sale price. So you're given an integer array prices. Ith item has price I, and we have an integer array needs, where needs is telling us the number of pieces of the ith item that we want to buy. All right. And then we are also having another array which is special. Special I is of size n plus 1. Okay, so special is a matrix, and the ith item in that special matrix is another list which is of size n plus 1, and special ij is telling us the number of pieces of the jth item in the ith offer. Okay, and special in is the price of the ith offer. Okay, now we have to return the lowest price you have to pay for exactly certain items as given, where you could make optimal use of the special offers. You're not allowed to buy more items than you want, even if that would lower the overall price. Okay, so we cannot buy more things, and I think each offer is like a set that the jth item is occurring three times. You cannot choose one or two or three. You have to buy all three, and the price of the jth ith offer is special in, right? So it's a clubbed price of all the items. Okay. So we have offers, we have individual prices, and now we know how much exactly these, like for each item, we know exactly the quantity that we want to buy. And now we have to minimize the overall cost. So the problem is clear. And for an example, there are two items, 2 and 5 is the cost. And then the offers are of, there are two offers. One offer is of rupees 5, the other offer is of rupees 10. In the first offer, which is of rupees 5, you will get 3 units of first item, whereas in the second offer you get 1 unit of first item and then 2 units of the other item. And now our needs is basically 3 2, and now the answer for this is 14. If you had purchased individually for, so basically let me write it over here. Okay, so the price is 2 5 and the need is 3 2. So, like, if you do not do much, if you do not put much of your thought into this, what would be the overall cost? Cost would be 3 star 2, right? Plus 2 star 5, which will become 6 and 10, 16. However, the optimal answer is 14. And how is that happening? It is saying that in so it is saying that you need to buy 3A and 2B. That's okay. You may pay $10 for 1A and 2B. Okay. So it is saying that take the special offer 2. The special offer 2, the offer 2 is basically 10 rupees, and it gives you 1 unit of the first item and 2 unit of the other item. So it is saying that take this. Once you take this, your need will become only 20, right? This is already procured. And then instead of 3, now you only need 2 more. You have taken 1 now. So to take 2 items of the first unit, you can buy them individually, and that will cost you 2 into 2, which is 4. So the overall cost will become 10 plus 4, 14, which is lower than this, and that is the optimal answer. So this question is good. Now the thing is, we have very, like, the constraints are pretty less. I think we just have at max 6 items, and then the prices are also very less. Each item is at max 10 rupees, um, and the need is also pretty less. Now the offer, um, okay, so the number of offers can be up to 100, and of course each offer will have size n plus 1. Okay, all right. So how would you solve this thing? That Okay. I think so. If you have an offer, hopefully the problem statement is clear. First of all, I think it's a good question. All right. I think this is a good question that you should definitely try to solve. And like, I will first of all discard any offer that has a higher price than buying units individually. So this is first thing that we will do. We will discard any offer that has a higher price than buying the units individually. If that is done, I think we will always use offers first, and the remaining fields for each item, remaining units for each item can be filled individually, right? So this is what we should do. Once we discard irrelevant offers, then we will always try to use offers. Now the thing is how to use offers, and I think one offer can be used multiple times as well. Um, yeah, so you can use special offers as many times as we want. All right, so this is good problem. Luckily, the thing is we have only 6 items, right? And up to 100 offers. So these are the constraints that we have to work with. Basic thoughts. So anyone is having any idea? Correct. The last element of the spatial subarray will represent the amount of the overall offer you have to pay, and you will get those units. So the second offer array was 1, 2, 3, 1 to 10. So 10 was the price of the offer, and 1 and 2 is representing how many units of each item that you will get from this offer. All right. I'm having some ideas, but it would be like, um, so how many units can it we have? Okay, up to 10. That's good. This is a good question, man. It's very like too many information we have and to process that. Um, Up to 10 items. Up to 10 items of each unit. Up to 10 units of each item. Each item is at max 10 rupees. Let's call it rupees. All right, I think we have covered all the constraints. And spatial is okay. That's fine. So I was thinking in the sense of using dynamic programming in the fashion that I can use a given offer one time, two times, three times, and so on and so forth, right? So what I was planning to do is I will iterate on all these things, and up to some time, up to some k times. After that, you cannot use a given offer because uh, the needs array will present that constraint on k. It will do that enforcement that a given offer can be used at max this many times, because after that, it might happen that some item is being given in that offer a lot much more than what we need, which we cannot do, which we are not allowed. So we want exactly these many units, which is mentioned in the array. So I was planning to consider all possibilities for a given offer. I want to use it X times, and X will vary from 1 to as long as I can go. And once I use it, I can do a recursion. I can say that, okay, this offer has been used. Let's move on to the other offer. And the only problem is your needs are is changing now. So in my state, I need two things. One is the offers I have, right? That is an offers array, and the other is needs array, which will also modify. Now, this is problematic because the number of states will be exponential over here, and the numbers are pretty high. Um, the offers array, the length is 100, right? And there are just so many permutations possible for the offers array. Or no, I think this is 100. Okay, I don't need permutations of that. I just need the index. Yeah. So this will be 100. That is fine. But the needs array, this will be about permutations, right? Because I'm having some needs array, something like 10, 30, 29. Okay, so up to 10 units of each item needed. So this is not valid. So 10, 3, 7, so on and so forth, right? And only six items at max. So 2, 1, and 5, something like this. So let's say six items, and this is the needs array. Now, the office array, this can be up to 100, like only 100 states are possible over here. But the needs array, I think the number of states which are possible is really big because the number of states for needs would be 10 into 3 into 7, which might be high, right? That is my only concern. 10 to the power 6, probably. And then office array is 100. So 10 to the power 8 sounds like doable, probably, and we would, and probably we will not hit all the states. So probably we can do this thing, which I'm suggesting. It would be really close to the time limit, but what I'm saying is we won't hit all the states of needs, and there are only six items, and each number can be up to 10. So the total variations possible are 10 to the power 6. And in office array we have 100, so to overall states will be 10 to the power 8, which is close enough to getting accepted. So probably we can do this thing. All right, so I'm going to do this thing. Uh, so let's use some recursive function to do the heavy handling for us. So let's say we have a recursive function, get min cost, and we pass in that we have how many offers. Like initially you have all the offers starting from zero index, and then we can say that our needs is same as this, and let's rename this like let's have offers, and over here we can say offers is special, right? And then prices, which is vector of int, so we can say this prices is price, and needs is something that I'm already passing. So let's go and implement this get min cost and offer index, and then vector int, let's pass by reference needs. All right, cool. So this is what I am having in mind. So I think this is making sense. It's not a greedy, it's this is dynamic programming. We are considering every possible scenario. So I don't think one problem is we have another loop over here. One offer can be used multiple times. So I'm not sure. Like I think this will pass the time limit just on the words if it does pass it. We can do some optimizations probably to make it work, but let's see how what is happening. Okay, so what can you do? So right now, the current offer, well, um, auto current offer is nothing but offers offer index, and then you can use it as many times as possible, right? For entire zero, I is less than, or probably we do not need this. Let's use it one time only, and we will keep the same index, so that can happen, right? So let's see if we can use the current offer or not. If not, we can increment the offer index and go to the next state. Yeah, that's also possible. So you either use it or not. Use it. Use current offer. Ignore current offer. So if you ignore the current offer, your answer is nothing but get min cost of offer index plus one, and your needs stay the same because you have not done any modification, and then you can do the return of answer. However, if you do use the offer, what is going to happen? Your needs is going to modify, right? So what you can do is, um, okay, so let's have int n, which is the number of items, and that is nothing but price dot size. So over here, I can say something like, I'm iterating through the items, and I'm saying that the price of current offer would be current offer price, which is nothing but it's an integer. It's offer current offer n. That is the price. And now I can say that needs I is going to modify, right? Needs I is going to modify. So let's create a copy vector int new needs equal to needs, and I can say let's move this outside. I can say new needs of I is minus equal to current offer I, right? Um, this is what I'm planning to do. And then I can say once I have modified the new needs, I can say that answer is the current offer price. That is something that you are paying. And now you can get the min cost. You have you can stay at the same offer so that you can use it multiple times. And your needs is modified. So I pass in the new needs now. Okay. So this is what I am having in mind. Um, so this is something which I think should work. And over here, we can do answer is min of answer comma this. Initially, answer can be uh, let's say int underscore max probably. So we can do something over here. Now there are a few things that we have to keep in mind over here. We are not taking into account that after a certain point of time, new needs can never be negative. They can only be zero. So over here, if new needs I is less than zero, then it means you cannot use the current offer anymore. So you can, at this point of time, you can say that move on equals true, bool move on equals false, and if uh, not move on, which means we can use the current offer, or you can say can use is false. If not, if can use, then do this. Otherwise, you have to ignore the current offer and move on to the other one. And a few base cases, if your offer index um, is same as offers dot size, which means you do not have any more offers possible with you. So at this point of time, what you can do is only if your needs is empty, you will return zero. Otherwise, you return a penalty of int underscore max. So you can say that for int x in needs, if x is not equal to zero, it means you do not have any more offers. Um, okay, so at this point of time, okay, yeah. So this is a bit tricky. Let me handle this case. Um, yeah. Int cost is zero, and over here you can say that for int x and needs, you can say cost plus equal to um, x times the price. So let's use a for loop instead. So you can say needs I times price I or prices I. That will be the cost, and then you can return that cost. So this will be the base case. You do not have any more offers, and this is what you try to do. All right. Um, I think this should work. Let me go through the code, make sure that I do not have some obvious bugs. Like in the last live stream, I was doing really horrible. So let me just go through the code and see if it's making sense. So I'm saying that if I do not have any more offers at that point of time, I just need to do the brute force thing in which for each particular item, how much quantity I need, that I will buy myself. So this is cool. This makes sense. Otherwise, what I'm saying is this is my current offer. I either use it or I ignore it. If I'm using it, well, my new needs would be something different. And my current offer for the ith item, the new needs will be decremented by that. If new needs is less than zero, well, I cannot use this offer. So if only I can use this offer, I pass in the new needs, I add the current offer price, and I for the remaining, I just get min cost and I use the function recursively. Otherwise, what I'm saying is if I'm going to ignore the offer, I'm doing a minimum of the answer with min cost of moving on with the offer index. And yeah, this makes sense. This should work. And I'll just quickly run the code to see if it's functioning. So it is saying, okay, so this is not, like I cannot take a reference of int underscore max. So my output is 16, well, whereas expected is 14. So I'll just debug this thing. Hope, but we are not getting compilation errors, which is good. Let me see if we have missed anything. And I'll also go through the chat section once. Yeah, you can use arrays as well, but vectors, they are very heavily used in C++. And of course, vectors have other things as well that arrays do not have. All right, I'll just be back in a minute. I'll go and have some water. All right, I am back. Okay, so our output is 16, whereas the correct answer is 14, of course. So let's see what is happening and why are we getting such a, like, obviously this answer is not right. So let's see what are the base cases that we are getting. So let's print, let's say the offer index, let's print that. And then let's print the prices as well. So we were at the zero offer, the need is 3 and 2. Then we went to 1. Okay, so we went to the next index. And the needs are same. So which means that I don't think we have covered all the states. We have never used the offer. So does that mean, okay, I think can use should be true initially, right? Okay, so now the answer is correct. And I think we are going, yeah, because I think the algorithm was right. So it should work. Now I do need to add some dynamic programming to this because it might happen that we are at the same state again and again. So, like how to use dynamic programming over here. Now this is a vector, right? So in my state, I can have a pair of int and vector, but then I have to tell how to hash that. Um, Let's try to first submit and see if the algorithm is correct and is the problem wrong answer or okay. So this got accepted actually. Well, we do not need to add dynamic programming over here. Cool. So I think this was implementation based and the constraints were also small and it was very tough to hit all. So as I was saying, the 10 to the power 8 is worst case. However, it's not 10 to the power 8. It can also happen you are using one offer multiple times. You can use one offer um, 10 units, right? So I think one offer could be used multiple 10 times. So overall, the worst time complexity was 10 to the power 9. However, it was very tough to hit that, right? Because you cannot, this will be much lower than this. This is the worst case, which will never happen. Like this is a very hard limit that I had set. In reality, this will be very less. Why? Because initially you are already given a needs array, right? And after that, the needs array can only be having some possible states. Like you can use one offer, one, two, three, or 10 times, right? So based on the, and there will be a limit because if this is one, then this means that you cannot use any offer more than two times. It will go less than zero. So yeah, something like that. So this is like hard, very hard to hit 10 to the power 9, and probably because of that, it's getting accepted over here. But good problem, and I'm happy to solve it in the first go. All right, I think this was an interesting problem, and you also had fun. Um, I think we should hit the like button on this one. A good problem. What about the stream, guys? I hope. Okay, so we have a bunch of people who are online. Make sure, like, before you move forward, I am just waiting for you to go and hit the like button on the stream. I already have a break after can use. Oh, okay. I don't have. That's good. So after a break, it is taking a bit more time. But yeah, this doesn't really add much a difference. The number of items is at max 6. So these are some social live stream etiquettes that when you're about to cough, you should mute yourself. All right. Should I do this one? I'm having second thoughts on solving this particular problem, so I'll simply close it. If you have any suggestions in the chat, oh, okay. So someone is asking about the um, regions graph problem. I do remember this. I think this happened in the first live stream in which I was not able to solve it. However, in the second stream, I did mention about it and how you could still use the Euler's formula for the regions and solve it. I was able to solve it, however, like my approach was fine. We could use that mathematical concept and extend that. In any case, like since a lot of viewers, like this is the 14th live stream, so I'm not going to dignify more on this particular problem. But yeah, we did solve it. All right, I'll select another problem. Let's pick something which has the acceptance rate really less. So this is 37.4. Let's do this one. I think this is a graph problem. So there are n and the likes is like really good. So let's do this, and then we can probably end our today's session. So there are n cities connected by some flights. You are given an array. Flight array is telling us what is the from and destination of the ith flight and what is the price of that. Now we are given three integers, which is source, destination, and k, and we have to return the cheapest price from the source to destination. However, it's not as simple as that. We also have the condition that we can take at max k stops. And if there is no such route present, we have to return a -1. So in this case, you can see that there is one flight from 0 to 1, another from 1 to 2, and then I think another from 0 to 2. And then the source and destination are 0 and 2, and k is 1, and the output is 100. So since k is 1, it means that you can take one stop, or you can take two flights, or you can take k plus 1 flights in total. Um, so one option was to take the flight of 500 directly with no stop, so one flight. However, we are taking two flights because you can take one stop, and this is a bit cheaper. All right. So at max k plus 1 flights, and what are the constraints? 100. And how many flights? Well, NC2. All right. Okay. So k can be up to okay, so k is up to n. That is good, right? K can be obviously it cannot be more than n. All right. So a very simple DP state which is coming to my mind is int cheapest flight or get cheapest. It takes three arguments. One is the source, one is the destination, and the other is how many steps are possible. And over here, we can simply return get cheapest with our source, destination, and k, right? And over here, what I can do is for int, okay, so let me plug in my charger once, I'll be back. All right, I am back. Let's, so where were we? Yeah, so now I was saying that from the current source, we will see what are the next airports or the next stops that we have. So next next airport or next city, whatever, what is it? City, right? So next city from a given source. So let's have some g of src. I will build this later on. Um, Now what I can do is return get cheapest from the next city to the destination, and now k minus 1. Now you can take these many stops, right? And over here, what we can say is if k is 0, so means no stop, and at that point of time, and this wouldn't be, so I think this is a directed graph, right? So the state should be not this, however, can say auto next city pair, and we can do something like okay, so not return, but we'll do evaluate. So answer is minimum of answer comma this. However, we also have to add the price of current flight, right? Um, and initially int answer is int underscore max, return answer. And over here, we can say if this is still int underscore max, let's store it somewhere. So this looks good. If case 0, no stop possible. At that point of time, what you do want is, um, okay, so K was how many stops, right? So if K is 0, it means you want to go directly from source to destination. I think instead of using this kind of thing, we can probably use, uh, or is it fine? I think this is fine. Okay, so if K is 0, at that point of time, I can say for int or for auto, again, same thing. Or just give me a second, guys. Okay, so one base case can be if K is -1, return source is same as destination, right? This is one thing which is possible. And also we can have if source is ever same as destination, we can return 0 now. And over here, if source is same as, okay, return int underscore max. So this means that now you cannot take any more stops, right? If 0 is, yeah, so I'm going one more below the base case to make my life a bit easier. Otherwise, I will have to replicate this code over here if I'm using 0 over here. I don't want to use that. So I think this does work. Like, let's think of this way. If 0, 2, and then K was 0, it means that you cannot take any stops, right? So at that point of time, yep, this makes sense. Yeah, yeah, yeah. So if source is destination, we can return 0. Otherwise, if K is, yeah, if K is -1, it means that the source is still not same as destination. So definitely return it as comma. Yeah, I think this will work. Um, I'm considering all the possible pairs, and I just need to build this graph. So vector of pair of int. Uh, how should it look? So vector of pair of int comma int, right? G, something like this. I guess so. Yeah, this I think this should work. This can be n. What is n? At max, you have how many? 100. So let's build this thing, and I think then we are done. Okay. So what you can do is int n is nothing but flights. Okay, n is given. So for int I is 0, I is less than n. And the flights are in 0 based index or 1 based index. Okay, so from and to is already in 0 based indexing. So I is 0, I is less than n, I plus plus. I can say g of I dot clear, right? That's one thing. Now the other thing is for auto flight in flights. For each flight, I'm going to build the directed graph. So I'm going to do that as auto from comma to is flight. And then I can say g from dot push. Okay, so there are three things, right? I can't do this. So I'm building the graph and then I'm calling get GPS. I think this should work. Let's see if this is functioning first of all. Seems to work on this one. Let's try to submit and see if you're getting a wrong answer or time limit issue. Okay, runtime error. Okay, so there is some overflow happening in some at some point of time. So I think okay, this might happen that this is returning int underscore max and then doing an addition with price is a problem. So one way to handle this is so what is the limit on price? The price can be 10 to the power 4. So instead of int underscore max, I can say that infinity, infinity, and infinity is nothing but, let's define it here, int underscore max minus, let's say, something like this. This should be good enough, I think. Oh, okay. So this will also be infinity. If answer is infinity, return negative one, right? I'm I'm hoping we will get time limit exceeded. Okay. So now the algorithm is correct. We just need to add dynamic programming, which is straightforward. Three, three, ten, yeah. So it's a 3D and how it's going to look like? Well, it's going to look like something like this. Int dp n n and n. And over here, you can say we need two more loops. So let's create that. And over here, you can say this is for j, and the other one is for k. And you can say that dp of I, j, and k is, um, let's say, unknown, right? What is unknown? It can be another constant, -3 or -3. Yeah, that is fine. -2 probably. And over here, what you can do now is int and answer. Just bear with me. So I'm saying int and answer is dp of source, destination, and k. If answer is unknown, it's not unknown, then return answer. Otherwise, do as you were doing. So hopefully this will do that optimization for us. And now it's a success. So guys, we were able to solve true problems. I think the idea and our approach was very clean, and our implementation was also like very clean, neat, clear, and it was not having any bugs. So I'm very happy with our performance today. Hopefully you were also able to solve these problems, and let me know in the chat section if you have any doubts. Yeah, this is not extra. Why do I have BlueStacks on your laptop? Probably from the next stream, I will hide what I have in my dock. I'm not sure. I experiment things. I do not use it heavily, but once when I was playing Among Us, at that point of time, I had installed BlueStacks just so that I could play it from my PC. And also a few other apps like Instagram. For Instagram, we cannot upload directly from our PC. So for that also I use BlueStacks. I used to, now I'm not using it that often. But yeah, for very few use cases. All right, cool guys. I hope this was fun. And um, if you're still here, and I hope we are like you guys are doing your interview preparation in a very peaceful manner, like how I'm doing, right? Like just enjoy problem solving. It might, if you're doing for coding interviews, that's fine. If you're doing just for problem solving, like how I am doing it, then that's really even more helpful because it you do not have any pressure of interviews, right? So it's very easy to do what I'm saying. Like just try to solve problems with for the sake of doing or learning something or able to convert your thought process into bugless code. So I try to do such things, and that is why I feel that I'm improving. Um, I used to be like when I was doing competitive programming, I was much faster than what I am today. However, I feel that the way I write code now or how I approach things is a bit more is it's actually much more cleaner than what I used to do initially. So, and that's what I think people care about. In a as a software developer, people care about how well you're able to communicate and how good you're able to write code. And I don't think the speed is still that less. I think while I am explaining and walking through each and every thought process, this is really great. How much is my salary? Well, I think this is the simple answer, which I also give to my relatives is, um, okay, dear everyone, there are three things that you should never or you should always avoid. Never ask a girl about her age. Never ask a college student about his grades. And never ask a man or woman, he, she, about her salary, his, her, right? So this is what I would like. This is how I would like to answer your question. All right, guys. I hope this was fun. I'll see you in the next one. Again, thanks to our sponsor, Educative, for sponsoring this live stream. And if you want to enjoy unlimited courses on the platform, you can go to educative.io/Rachit, which is highlighted in the top right section, to enjoy additional 10% discount. So the overall discount is 46%, which I think is really great. So that's pretty much about it. I'll see you in the next one. Till then, happy coding.